Number 9 says sketch the graph of a function f satisfying all of the following properties. Now we were given 6 properties here, but keep in mind that you may not be able to do this in the order in which they were written. And sometimes you may not be able to apply every piece in its entirety. So I'm going to kind of walk you through how you can sort of logically piecemeal a version of this graph together. So the first thing gives us our domain, and it's kind of hard to check the domain when we haven't really drawn any other elements of the graph. So you always want to make sure at the end of the problem you go back and you scan your picture and you make sure your domain fits this function. So the first thing that I was told was that the limit as x approaches -1 of f of x equals 1. But I was also told here that -1 is not in the domain of my function. So that tells me that if the function is approaching the value of 1, that point cannot exist on the graph. And if you don't catch that at first, it's okay. When we go back to do the check at the end, you verify that. So remember, the limits tell you how the function is trending around that value. So if we come down to our graph, here's -1. The limit is a two-sided limit, and it says that the graph is approaching a value of 1. So I generally draw all these points with the limits as open circles, and if I find out later I'm allowed to fill them in, I fill them in then. So the limit, as it's coming from both sides, is going to hit that point. And I don't know really where to connect it, but I know that from the left and the right, it's got to be approaching that circle. So I'm going to go back up, and I'm just going to tick that off because I've addressed my limit. Closing in the point, we can do that with the domain later. Then I'm told that the limit as x approaches 3 from the left is positive infinity. When a limit equals positive or negative infinity, that is the indication of a vertical asymptote. When the value is approaching a real number, it means the graph is riding up to positive infinity or negative infinity. So I'm going to come to my graph, and at 3, I'm going to draw a dotted line to indicate that I most likely have an asymptote there. The graph is going to ride this line in some way up here, but I'm not really sure what's happening in here yet, so I'm going to kind of put a pin in that for a minute. I am told in the same line, however, that as you approach 3 from the right, the value of the function is 2. So I'm going to come back down to my picture, and as I come in 3 from the right, I'm at 2. So I'm going to put an open circle there because I'm not sure if the point exists or not. I just know that on the left it rides the line, but we don't know exactly what's happening here. But I know the graph is coming in from the right to that location. F of -4 equals -1. That's a point. You can just flat out plot that. So -4 is down at -1. So we have a closed circle there. In the same line, I'm told that f of 2 is equal to -2. So that's another point that I'm allowed to plot. So this line is taken care of. F is continuous at every point in its domain. So that means when we do the domain check, all of the lines we're going to draw in between the holes we're given in the graph are going to be solid lines. There's no more breaks or gaps. The next thing we're given is a chart, and it says that the graph is increasing or decreasing accordingly to the following behavior of the graph. So from -6, and notice this is closed here, from -6 to -4, the graph is decreasing. So it doesn't give me any more information about what's happening at -6, so you really have a lot of flexibility here on where on the y-axis you decide to start or stop this point. So I can put a closed circle anywhere I want, and it's closed because of that bracket right there. And I'm going to let the graph come down and hit -4. So there's no right or wrong way to do this as long as it's decreasing till it gets to that value. Then we're told that the graph is increasing from -4 to 1. So that means the graph turns and starts going up, but we know at 1 it's got to hit this location right here. So I'm going to have it come up and connect to my dot here. Then from 1 to 2, we're told it's decreasing. So that means from here to the point we drew down here, it's got to drop back down again. So I'm going to bring it down and connect it to my point at 2. Now here's where the limit comes in. We were told as the graph approaches this line here, its limit is positive infinity, so that means it's got to leave this point and start heading up, right? And never touch that line, but just ride it up all the way up. Once again, you can be as dramatic or not as long as you don't cross this dotted line. Then we're told from 2 to 3 we're increasing, so right, we just took care of that. Then we're told from 3 to positive 6, it's increasing. So once again, at positive 6, I can put a point anywhere I want to put it, and this graph has to increase up to that point. So now the last thing I want to do is go back and check my domain. And it says from -6 it exists all the way to positive 6 it exists, but not at -1 and not at 3. So if I check my graph, we leave this circle open because the function doesn't exist there, and we leave this circle open because the function doesn't exist there.